This is John Gilroy from the Federal Tech Podcast.
And this is Emile Monette with Synopsys.
Today, we're going to talk about open source security and much more. Hit the music, Manny.
Welcome to the Federal Tech Podcast, where industry leaders share insights on innovation with a focus on reducing cost and improving security for federal technology. If you like the Federal Tech Podcast, please support us by giving us a rating and review on Apple Podcast.
Welcome to the Federal Tech Podcast. My name is John Gilroy, and I will be your moderator. Our guest today is Emile Monette from Synopsys, S-Y-N-O-P-S-Y-S. Easy to say, hard to spell. But first, I would be remiss if I did not tell the audience that we are recording this at Ford's Fish Shack in lovely downtown Ashburn, Virginia. Why here? I think everyone listening knows that 70% of the world's internet traffic flows through Ashburn. What a better place to talk about open source security than here. Do you agree, Emile?
Absolutely, John.
Okay. So, fancy pants title, Emile Monette, Director of Government Contracts and Value Chain Security at Synopsys. Tell us a little bit about Synopsys, please.
Sir, thank you so much for having me on the podcast. I would be remiss if I didn't start with, a hearty, happy Supply Chain Integrity Month to you and all of your listeners, since we are in April, and it is, of course, International Supply Chain Integrity Month. So Synopsys, it's one of these companies that's, really big and kind of old. It's 35 years old. We got 20,000 employees. We have a global footprint. We're headquartered in Sunnyvale, California. And to be completely honest, before I joined the company about 3.5 years ago after my federal service, I really didn't know what the company did. And come to find out that Synopsys technology is in just about everything that we use every day. For example, USB technology. Everybody knows what a USB drive is. That's Synopsys technology at the core of what makes that work. And we have a whole suite of best-in-breed software testing and validation tools. We offer all kinds of different services around chip design and validation and verification.
Good. I've done many interviews, and very few times have I written down 1986 for a company that's been founded. I mean, that takes a long time for someone to keep on top of technology. It's like riding a wave. I mean, somehow you guys have managed to ride the wave in a very, very difficult world, isn't it?
It really is. And I think the credit there goes to the really smart people that founded the company and actually kind of founded the industry of EDA. What's EDA? It's electronic design automation, right? Well, okay, what does that mean? It's basically like automating your drawings like we do for CAD for houses, right? For buildings, but it's for chips. So it's an AutoCAD for chips, if you will. And that was the foundation of the company. We also are the number 2 largest in the world we own semiconductor intellectual property. I mean, you say, okay, what is that? So the semiconductor intellectual property that we affectionately call IP are pre-designed circuits that you can almost think of as building blocks for a chip. So when somebody, say an Apple or a Samsung or somebody wants to design a new chip, they come to us and they license out some of these pre-designed circuits to build the functionality that they want on that chip or that system on a chip. So those two things really are the core of the company. And maybe 7-8 years ago, the company started buying software testing and validation companies, right? And we've put together now this suite of products and services that has gotten us the upperest and rightiest on the Gartner Magic Quadrant for 6 years running now, and we are broadening that gap between us and our competition year over year. And the reason for that is we're a $5 billion a year company. We just went over $5 billion this past year, and we invest more in R&D than many of our competitors have as gross revenue. Right, about 35% of our profit actually goes back into R&D, and so we're able to keep our products at the forefront of technology where they need to be.
The people who are listening to this podcast, I know them, they're govies or people who work with the federal government. When they hear CHIPS, they think of the CHIPS Act. And this is a big deal. I mean, this is, there's Ron Burgundy, this is a big deal. No, this is really a big deal. I think it's a $50 $52.7 with a B billion-dollar CHIPS Act. And what they're saying is that we want to start manufacturing chips right here in the United States. And it seems like it's a perfect setup for your company, for Synopsys. I mean, if you look at the statistics, and I love me some numbers, here's some statistics that I just found out this morning. In 1990, America produced 40% of a global supply of chips. 2022, 12% of the global supply of chips. So that's right in your sweet spot, isn't it?
It is. As a nation, we have maintained superiority in the EDA, electronic design automation field, but all of the other capabilities, manufacturing, packaging, so on, all the things that it takes to get that design into a physical embodiment and a chip and then go into a device that one or the other of us uses, a lot of that has gone offshore. And that, I think, is the big goal of the CHIPS Act is to bring at least some of that capability back to either the U.S. soil or friendly nation soil. It is a big goal. And we got a lot of work to do. $52 billion is a decent priming of the pump, if you will. But we really need to focus on changing the market conditions that will allow that investment to sustain itself for longer than the 5 years or so that it's going to take to roll this out.
When I was in high school, they forced me to read Shakespeare. I remember these catchphrases. Aye, that's the rub. So let me give you the rub here. The rub is here that in some estimates, the United States needs at least 50,000 new semiconductor engineers over the next 5 years. Well, where the heck are you going to find those, Emile? I mean, look under chairs at restaurants like Ford's Fish Shack?
Yeah, I mean, I could run around here and collect up some children and see if, see if I can get them into some STEM education, right?
Maybe.
That's a tough nut to crack, right? And if you look at our graduate school population in our universities here in the United States, a significant portion, maybe half, maybe more, of those students are not foreign. They are not U.S. citizens. They're foreign nationals. And what happens? They come here, they get an education, best education you can get in the world, and they go back to their home country and they compete against us.
Yeah.
And so we need to address that. We also need to really emphasize that STEM and STEAM education for our youngest kids, right?
A lot of people talk about looking at the market, and they say, well, there's a shortage of software engineers too, so maybe robotic process automation is the key there. Well, what about with the design of semiconductors? Maybe electronic design automation. Maybe that's the connection there. Is EDA, is that what the connection is?
It is, and we are actually starting to use AI in our EDA tools and in our what are called flows, which is a chain of tools put together to design a chip. We use AI to speed that process up, as well as with the verification and validation work that we do.
Well, I'm trying to impress all the physics majors out there and all the EE people out there. So I'm going to use a big fancy pants word, and you can tell me it's going to impress anyone. Maybe in the restaurant here or something. It's called Microelectronic Quantifiable Assurance, MQA. Does that impress anyone? Does it impress you? What does it mean anyway?
It has impressed itself upon me. And many others, I assume. No, I joke. The Microelectronics Quantifiable Assurance, mouthful, which we call MQA for short, is really part of what the DoD is now calling the Microelectronics Assurance Framework, the MAF. The MQA portion of the MAF came from a requirement in the National Defense Authorization Act of 2019, Section 224 of that NDAA, required the department to establish some standards for chips, and both commercial chips as well as more specialized use chips, custom IC, custom integrated circuits that are used in some of the more sensitive applications in the department. And so that effort, has gone along now for a couple of years, and there are some programs underway now. One of them is called RAMP, another one is called SHIP, and those programs are really the test bed, or the test bench maybe, for this microelectronics quantifiable assurance process. If you boil that MQA down into what its essence is, it's really about getting data, objective measurable data, about the design and manufacturing processes that can be used to then validate and verify those designs and those chips are working as they were designed. Right.
Emile, I got up early this morning and I did my research for this interview. I went to synopsys.com and I stumbled on this little report and I said, my, what's this all about? What's this got to do with chips? It's called the Synopsys OSSRA report, and it looks at open source code. And I saw some numbers, and I said, nah, I don't believe these numbers. So tell me about this report and how it got under the rubric of a company that handles a lot of chips and chip design.
Yeah. So, I mean, part of the reason, let me get to your question in a moment. I'm going to kind of back up a little bit. Part of the reason I came to Synopsys is that, as you know, I've been working in ICT supply chain is sort of the field that I've been working in for a dozen or more years now. And, as a guy who is passionate about securing our technology supply chains, thought about it for a minute, and if you want to secure that supply chain, you got to go as far left in the life cycle as you possibly can, and you got to go as far down the technology stack as you possibly can. And where does Synopsys sit? Well, we design chips. There's not a whole lot to the left of that in the life cycle. And we make your software better, right? We help you develop secure software. So between those two things, if you start with those activities and make sure they're secure, that's a good story to tell. You can tell the story that goes all the way up the stack about security. So let me get to the what we call the OSRA report. This is our 8th year doing it. It is the Open Source Security and Risk Analysis, OSSRA report. And it really provides it's an annual look at the current state of open source security, compliance, licensing, and code quality in commercial software. This year, we anonymized the findings from over 1,700 commercial code bases across 17 industries. We use our software composition analysis tool called Black Duck, and our audit team that often services M&A activities, uses that Black Duck tool to analyze these code bases, and then those audits provide a comprehensive, highly accurate software bill of materials, SBOM, that we've heard a lot about recently. And that SBOM covers the open source code in the code base, the third-party code, the web services, and any APIs in all of your applications. And so, yeah, there's some rather frightening and discouraging numbers in the report here.
I can't wait, Mom. I can't wait. Tell me the numbers. I mean, you looked at 1,700 code bases. So what'd you find?
So, as you mentioned, 96% of the audited code bases contained open source components.
No, I think most people would believe that.
Okay,
I believe
that.
Okay.
Yeah, I mean, that's not crazy, right?
Yeah.
Nobody thinks that's nuts. Now, here's one that kind of surprised me. Of those code bases that we audited, the percentage of open source in them was 76%. So that's like 3/4 of the code that we are all dependent on every day for various things is open source. Okay, well, that's great. It was free. Maybe this is cheaper.
Yeah.
Well, it's free. You get what you pay for in some instances. And open source in particular requires management and security audits, and you have to pay attention to your licensing and what vulnerabilities are in the open source packages or components that you use. I'll give you some more of these numbers. So I'll just touch on a few of the industries here. In the aerospace, aviation, automotive, transportation, and logistics category, 100% of the code bases in the sector contained open source. All of them. Okay. No big surprise there, right? For that sector, 73% of their code was open source. So again, kind of aligns with the bigger picture. Now here's where it gets ugly. 63% of those code bases contained vulnerabilities deemed to be high risk. And oh, geez, okay, what's that? Well, that's with a CVSS, a severity score of 7 or higher, right? And so those are the ones, if you're a code developer, those are flagging. You gotta mitigate those things before you go live. Energy and clean tech, 78% of the total code was open source. 69% of that contained high severity vulnerabilities. Retail and e-commerce. This is kind of amazing, right? There is a 557% increase in high-risk vulnerabilities in this sector since 2019. So the problem is not getting better, right? We are not doing a better job of managing our open source code bases.
So some people call that operational risk. Is that what we're talking about?
That is
this
absolutely.
Is the focus. Operational risk.
Operational risk. And then something we are fond of saying at Synopsys is that software risk is business risk, because every business runs on software these days.
I'm going to quote a very famous software developer named Ron Popeil. and he had a product on TV. It was called, it says chicken cooker, set it and forget it. It seems like what's going on here is a software developer or a team will put together some open source, and they'll focus on tweaking and making sure the features are good and user interface, and forget all about the maintenance here. And all of a sudden, you have code that's risky.
Yeah, and you may not even know it until sometime later, until you take a deep look at that code base, right? You might go to your favorite repo and pull down an open source component, and you know that container has the 5 things that you're going to want your software to call on. But did you check the other 15 things that are in that container when you pulled it down? What are they? Is that a driver for a product that's made by a company that's on one of the bad guy lists at Department of Commerce or DOD or somewhere? Those kinds of checks and that kind of hygiene is unfortunately not very common today, and we need to improve it.
And there's deadlines, and there's lack of staff. For a while, many federal agencies didn't have CIOs. There was encouragement to get things done quickly, and you can't blame them in many cases.
No, it's right. Incentives, right? It's all about incentives, and when you're incentivized by did you get that code out by date X or under cost Y, then you're going to behave in certain ways. So we have to put a value on this idea of properly managing, in particular, your open source software, but your entire code base needs to be managed in a robust way.
So I'm going to toss out some numbers, and you give me a shocked face. And so operational risk here, if you read the report, 89% of the code is more than 4 years out of date.
Right.
It sounds like my wardrobe.
Yeah, exactly. I resemble that remark, John.
I mean, 4 years out of date. What have they been doing?
It is that set it and forget it mentality, right? Because you think, okay, I got this component down from the repo. I put it in my code base. It does the things I want it to do. It passes all my functional tests, and I'm done. I don't need to go back and look at that. I'm going to build features instead. Somebody wants a new button on their user interface. Okay, I can do that. Instead of going back and checking, it's sort of the what one of my friends from the UK Cyber Center often says is it's the dull but necessary, and those are the things that we get caught up on all the time.
My. Here's another fun fact. Here we go. 91% contain code that was out of current version, and it's repeating the record's playing over and again. So it's not the current version. It's out of date. I mean, and then another one, 90%, no development in the last 2 years. So they've put it in, and they've worried about 52 other things in the last 2 years, huh?
Yeah. And what 0 days are sitting in there? One of the benefits of open source is that continuous, CI/CD kind of a environment where lots of people look at the open source code and improve upon it, sequentially over time. And if there's none of that activity going on, then you've got all kinds of risk for vulnerabilities that have been discovered in that time that then weren't patched, or even 0 days that existed before you pulled it down.
So if you want to take a look at this report, you can go to synopsys.com and go for the OSSR report, OSSR. This is the 7th year doing it. So eighth year. So what kind of trends do you see?
Unfortunately, not really good, right?
Bad trends, huh?
Some of those sectors, as I mentioned before, had real increases over time in their vulnerabilities. We are seeing some improvement, right? I mean, we see improvement in our customer base because the tools that we have for managing your open source and other code base highlight these vulnerabilities, and it's almost like spell checker on Word. It pops up, as you're coding away in your development environment, and you code something in that's a buffer overflow. It's going to tell you right then, boom, you're putting in a buffer overflow. Here's how you fix it. And so we see improvement in our. First, we use we drink our own champagne nightly. We run our own tools on our own tools, and we find our own issues just like everybody else. Software is software. But outside of our customer base, it's still a bit of a wild west. It's still a bit of a scary place.
So I'm trying to categorize your company. There are people listening who've never heard of your company. So do you go to cybersecurity conferences? Do you go to software developer conferences? Do you go to Silicon development conferences? I mean, are you on a plane all the time? I mean, RSA. I think you'd be at RSA. Just our previous discussion, just this whole report.
Yeah. We will be at RSA. I don't know the booth number, but you'll be able to find us. Just look for Synopsys. You'll see us, and please do come visit. We've actually got some sort of announcements that are happening around that time, maybe beginning of May, that are some new product announcements that are going to address some of the things that are kind of currently in flight, right? That flow from the executive order on cybersecurity, EO 14028, and the NIST special publication 800-218, the Secure Software Development Framework, and again SBOM. We've all heard about SBOM. Well, those kinds of things we can help you with, right? And those announcements that are going to be made later this month or early May are going to be worth your time. If you're interested in having a secure software development process and having a secure code base, come see us and we'll hook you up.
Years ago, when I was writing for the Washington Post, I wrote about this company called Intel, and that's where I learned the word Sunnyvale. And that's why I learned how expensive these fabs are. This isn't just like another McDonald's in the corner and then a fish and chips place next to it, another Ford's Fish Shack. No, it's really a serious investment. And so, I used the number $52 billion. It's one thing to throw money at a problem, but it's another thing is that you're going to have to find land in Ohio and zone it and then manufacture the plant, then go back to ground one and find one of those 50,000. Is 5-year plan, 10-year plan for the CHIPS Act? Is this going to happen overnight? It seems like there's some major challenges here. You can't there's no magic wand.
There's no magic wand. There's a reason why all this chip manufacturing capability has gone offshore. It's economics partially, but it's workforce also. And it's not just labor, it's all of the workforce that supports the entire ecosystem. And you're exactly right. Fabs are not cheap. I think I've heard that the cost of one of the advanced lithography machines that are required to make the really leading edge chips is $250 million for one machine. And there will be 10 to 12 of those machines in a single fab. So, just the machinery alone, let alone the floor you got to put it on that's vibration proof and all of the air handling and the purity of everything that goes on in that facility. It's a really expensive proposition.
Going back in time, there used to be a TV ad for BASF. It said, we don't make music, we make it sound better or something. And so when I think of your company, it's Synopsys. We don't make the chips, we make the chips better.
We make them better. We make them better, yeah. We do have, of course, there is a marketplace for EDA, and there are certainly other companies that we compete with, and that's healthy, right? But we are the best. That's another part of the reason I came to the company, is it's really acknowledged as the leader in this space, and I think that goes back to our commitment to R&D, and to be fair, the way that the company treats its people. Right? None of us leaves a job because we hate what the company does, right? We leave a job because we don't like the person we're working with or whatever, or the company doesn't treat you right or something along those lines. And Synopsys is really, really good to its people.
So I'm going to ask a question that maybe the guys in the suits and ties will come in and arrest us in the next 5 minutes or something. I would think that people in the intelligence community might be interested in where some of the hardware their use is designed and what's in that design. I would think there would be someone who would be knocking on your door asking about, what about this product A, what about product B? It fits in with your whole the philosophy behind the company, doesn't it? This is what they want. They want to make sure that we're sitting across the street from a data center, and I don't know how many servers are over there. Tons. But where are the chips inside those? Where are they designed? What's inside them? You're asking the next question. Talk about shift left. This is left. This is really the questions that the IC companies
There's not
ask.
a whole lot to the left of design. Maybe sand and rare earth minerals, right? That's kind of where you're at. That Black Hawk, the black one outside, that's mine, right? I'm not going to take off right now, but you might hear it later when I do. The intelligence community, of course, our Department of Defense, and those needs, those requirements really come from protecting our national security, protecting our economic security, and at the end of the day, protecting lives, right? It's the lives of those soldier and airmen and Marines that are out there on the front lines doing the things that need to be done for our nation that we are protecting here, right? And we take that very seriously.
So if you're listening to this and couldn't jot down that report, I will put it in the show notes. It's the OSSRA report. Go to the show notes. You can click there and download it. and we're unfortunately here running out of time. You've been listening to the Federal Tech Podcast with John Gilroy. I'd like to thank my guest, Emile Monette, Director of Government Contracts and Value Train Security at Synopsys.
Thank you so much, John.
Thanks for listening to the Federal Tech Podcast. If you like the Federal Tech Podcast, please support us by giving us a rating and review on Apple Podcast.